Gentlemen, good afternoon. I am thrilled to be here today to introduce a distinguished guest who will be delivering a captivating talk on a topic of immense importance in today's digital age. It is my great pleasure to introduce Professor Yannis Ioannidis, a renowned expert in the field of computer science and a trailblazer in the realm of data-driven innovation. This introduction is not by me, it's by ChatGPT. And it is a bit pompous, but anyway, I like that. So, more seriously, it's my pleasure to have Yannis here. Yannis is a very good old friend of data management community in Italy and in Rome in particular. He got his PhD from UC Berkeley. He's a professor now at the National and Capodistria University of Athens, and also an associate faculty at the Athena Research and Innovation Center in Athens. So he's actually a very well-known computer scientist with many contributions on different areas, such as data management, information systems, human-computer interaction, data science. In particular, in data management, he made outstanding contributions in different sub-areas, like database theory, deductive databases, query evaluation, user interface. In particular, I would like to mention a very nice result about query containment under bag semantics, which is the real semantic of SQL. Most of papers on query containment and reasoning about queries is about set semantics, but Yannis studied with Raghu Ramakrishna the problem of query containment under the real semantics used in the real world. They had very nice undecidability results, and for union of conjunctive queries, by the way, it is still unknown where it is decidable for conjunctive queries. So, but Yannis has also provided many contributions for services to communities, and this kind of activities has culminated in the role that he has now, the president of the ACM, and I think this is something that also is mentioned in the talk, maybe mixed with more technical aspects of data management. So welcome, Yannis, and thank you for being here. Please.
Thank you very much, Maurizio. It's a great pleasure to be here. I've been a visitor of the department, collaborated with Maurizio a lot, with Tiziana and others, and it's always great to come back. It has been a few years, and now we made a pact that I'll come back sooner than the previous time. So I'll try to give a tour in the next, 50 minutes to an hour of a few things about ACM, because I take advantage to talk about ACM. The broader spectrum of ACM that many are not aware of, and a particular initiative that is currently active. And then I'll talk about open science, which is, there are technical things about it, but it is more of a policy and everyday life for us, researchers, academics. And then I'll show how some things that, ACM cares about open science, and open science, the way we do it, has brought up a few things, and I'll finally, I still do some research, and so I'll give you a glimpse, no depth at all. So let me start from ACM. How many of you are ACM members? My breath is so less than a third. Madam Chair, you have to make sure that everyone becomes an ACM member. So let me give you a few things about ACM. This is the front page. It is, as it says, it's advanced. The goal is to advance computing as a science and professor. ACM.org is the website. Do go there and check and see what is happening. And there's no pointer, right? No, that's fine, that's fine. On the left, you see open call for presidential task forces. It's a video where the president of ACM, yours truly, for 40 seconds is trying to motivate you to do some things. 40 seconds of your life, go click and you'll see, but I'll talk about it later, so this is there. ACM, last year, it celebrated 75 years of existence. It's the oldest and largest professional society for computing. Some of the letters in the week when ACM was formed, in the September of 1947, where John von Neumann, I mean, all the computers that we use, except for quantum computing, use the John von Neumann architecture, said, I like this, but maybe we're not ready to form a society. Well, about a week afterwards, I mean, this is my personal opinion, it's very desirable, but not yet. Well, thank God, despite his stature, people did not listen to him. And a week later, the secretary of what was called Eastern Association of Computing Machinery got 75 people, somewhere in Philadelphia, and decided to form ACM. And they said eventually we can go national and not just be Eastern. And a few years later, it became ACM. So von Neumann never became a member of ACM. Hopefully this will not be true for the rest of you who are not already members. But it moved forward, and I'm glad they did not hear what von Neumann had to say. So, I mean, ACM, from the 75 people that first day, now it's about 120,000 members. And about 4 million people take advantage of ACM, engage with ACM, benefit from the digital library, from the conferences, and so on and so forth. So there's a big gap about what ACM does and who are members of ACM. There are 38, as academics, what we mostly know about is the special interest groups where we belong. There are 38 of them. They're thematic. SIGMOD for the management of data, where us, SIGCHI, that's computer-human interaction, and so on, 38. But there are 180 professional chapters where we have the SIGCHI Greece, for example, computer-human interaction Greece. It's a combination of geography and thematic. People get together more locally. SIGMOD Russia, ACM Mumbai without a particular SIG, or ACM Women Europe. So there are various combinations where people can come together more closely and do that. And there are 680 student chapters, huge number, always regional, where students in a university or a cluster of universities come together and work on that. My university has a student chapter, and before I became president, I was the advisor faculty, Bangalore, UCLA, all over the world. But one is missing. There is no student chapter in your department, and it's the activities are many, and it's a pity. So very quickly, and usually it doesn't start from faculty, it starts from students. So whoever of you are students, undergraduate or graduate, pick it up. You can go again to the website and check on chapters. You get some money from ACM, and then you have a whole bunch of activities to develop your career, to do things next to what you learn from your regular courses and so on. You have a chance to invite ACM distinguished speakers. It's exchange ideas, be mentoring, very important thing. Distinguished speakers, ACM has this form, this concept where people apply and then they are accepted, and they are distinguished speakers. I mean, you have to be good in your research and science and speakers, and then you get to be invited to give talks, usually by chapters, but also in general. And if we look at all the hundreds of distinguished speakers that exist, they are all over the place. These are the countries, and as you can see, half of them are in Europe, including Italy. So somewhere in Italy there are distinguished speakers. So we can take advantage of this service, if you want, of ACM and invite people. And for student chapters, this is amazing. I've experienced this a lot. Also, there's this ACM research student competition where students participate with their research in their thematic main conference, special interest group, and so on. and then there are awards across entire ACM, both for the undergraduate and for the graduate and the undergraduate place from all over the world. And you see those that got the awards for 2022. And next month, they will be in the award ceremony. We are mostly dealing with the conferences of ACM. So the research and the legacy of ACM has been research, science, and so on. But there are many other transversal issues that ACM has boards and councils that take care of it. Diversity, equity, and inclusion is a very important thing on how to become less male and less American. What do you do about people in industry? There are many more people in industry than in academia. How do you educate? What do you do about education? The standard curriculum for university-level computer science is done by ACM and IEEE, but also in other levels. And then how do you advise policymakers on issues of computing technology? Because usually the politicians have no idea what the issues are and how do we advise on ethics and so on. And three more things. One about how do you govern all the SIGs, and then the digital library and publications. Divesh Srivastava, did he give a talk here at all this time? Not this time, okay. So another a well-known researcher, but another good friend of the department, is a co-chair of the publications board, who decides what kind of journals to have, who can be an EIC, and faculty of this department have been EICs in many ways. ACM Turing Award is the Nobel for computing. It's ACM that is giving it. This year, the Turing Award goes to the one to Metcalfe, who came up with Ethernet. 50 years ago, the Ethernet was established, and we all use it. So he got the Turing Award and ACM Prize in Computing. And let me say that there is, for mathematicians and computing scientists, are the two main fields that don't have a Nobel Prize for. So those that get the main ACM awards, the Turing Award and ACM Prize, and the Abel Award and Fields Medal and the Valina Prize in mathematics, the 5 winners across the years get together for 1 week in Heidelberg. The Klaus Schira Foundation from SAP fund this, and for a week, 100 computer science students and 100 mathematics students get together with these rock stars of mathematics and computer science for a week, and they rub shoulders and they connect and so on. It's a very high adrenaline, high excitement work, and it's an amazing experience for students. So I'm not sure how much Italians participate. I have seen a few, but be aware and apply, of course. So the ACM mission is not just science. This is the mission. I won't read it, but there are a whole bunch of things that I want to emphasize that ACM is not good at. I mean, there are usually some reds. It's not as global as it should. It's half of the members are American. It takes care of science, but not of industry or the applications, bio applications, medical applications, and so on. And when I was a candidate, I promised, based on input that I got from the members, that I'll form some task force to deal with key issues. And after I got elected as president, not being a politician, I mean, if I were a politician, I could just ignore what I promised, but now I could not do that. And I went back and I saw that I had promised 10 task forces on 10 key things. The first 3 are about changing how we attract members. How do we make them global? So many more people around the world to join ACM because it is a global organization, and how to attract the young generation. And the last 2 I want to emphasize because these are things that computing technologists, computing scientists Until now, we've been playing in our sandbox, creating things without caring, just having great fun. But now we run the world. There is nothing that society does and is not affected by computing. And we cannot just keep up with our fun times. We are responsible towards society on what we produce and how it is used. So on two levels, there are two other task forces that are formed. One, on how we can help joining forces with the United Nations and so on to solve and accelerate our process to achieve the 17 Sustainable Development Goals that the UN has established. How many of you have heard the 17 Sustainable Development Goals of the United Nations? Okay. In 2015, the United Nations, unanimously, 193 countries, established 17 very high-level goals for humanity. For example, have a climate action, eradicate poverty, achieve equality among the genders, and so on. Really huge tasks. And they said, if we don't achieve these, our Earth, our society, our humanity is not sustainable. We eventually will disappear. Okay? What can we do? And none of these 17 Sustainable Development Goals can be achieved without computing, without the technologies that we produce. So how can ACM help in joining forces with the United Nations and so on and so forth and provide pathways for computing people to help there? And the other one is social responsibility. Everything that we produce may affect us. I mean, our privacy is in danger, democracy is in danger, face recognition in the streets, a whole bunch of things, plus smart weapons and so on and so forth. How do we put in the ethics next to our technology? I mean, our technology should not stop. I mean, you saw ChatGPT, you saw the wonderful introduction that ChatGPT wrote for me. I want a copy, by the way. I'll show it to my kids. And you know, it was dropped like a bomb in society, and then fear started or excitement started, you know, but not really understanding what was this about. So we are socially responsible, and ACM will help on that. And the other 5 have to do with inner operations of ACM and the service that offers, but the second one is about open science, and then I'll spend some time. So if you look at the 5 dimensions that organizational theory says are the main things of a strategy for any organization, including ACM, and if we serve our members in society, the 10 task forces make sense because they do apply to who we serve and how we operate. And next to the permanent bodies, you see that there's a whole portfolio of things that ACM is trying to do in addition to what we are used to, which is the conferences and journals and publications that we are there. The steps, all this have started, of course, after I took over as president and I looked at what happened. We are now in May 23, and you see right here that the open call exists. It opened only 10 days ago, and the deadline is next Monday. So you still have time, and I ask you, go and check. It doesn't matter if you are ACM members or not. The task forces will be populated. I want to populate them also with people who are not members, because this will give much more input on how ACM should progress. There are currently more than 500 volunteers around the world on many items, and we want more to get the most appropriate for every task force. If you just go to acm.org, and then you'll see the open call, please volunteer. That's the website. Open science. Any questions about ACM before I go into the next topic? Okay. As I said, in one of the 2 slides where I showed the 10 task forces, open science is a major target of ACM. But it's a major thing, not just for ACM or just for computing. The entire scientific world is talking about open science. And it's talking about open science both because scientists themselves want to operate in this way, not everyone, because not everyone is aware of, but also because aspects of open science are mandated by governments. It's a standard in Europe. It is a mandate for January 1st, 2026 in the US, Canada, Korea, around the world, I mean, with exceptions, of course. China is not thinking about open science working there. But it's not an issue of computing. It's for the entire field. How many of you have heard and kind of understand what open science is about? Okay, few. Well, I'll give you some highlights, some things that are a bit controversial, but I think they show the direction we should move, and then we'll see where we'll converge, and so on. Let me first connect to ACM. That is the process of ACM Open, which says that currently, in order to access the digital library, the ACM digital library, you have to have a subscription. You have to have paid for this, or if you want, you pay per individual paper, $30 or something like that to download it. The ACM Digital Library is scheduled to be completely free and open in 3 years, January 1st, 2026. Yeah, for everyone. Of course, openness is not for free, it is a cost. So instead of the readers paying, the authors should be paying. And then there are various schemes. ACM has chosen a scheme where it's not the authors that pay, but instead of a university library, for example, paying to read, the universities that publish a lot pay to publish, and then the authors just publish because the university has paid. And then about a third of the lowest ranking in terms of how much they write papers, universities will not be paying anything, because the high flyers, you know, the Oxfords and the Stanfords and so on, and the Sapienzas will be paying the big numbers. ACM opened up its first 50 years because of the celebration last year as a token. It was the first 50 years, which is 2/3 of its life. It's 20% of the publications. I got excited because the number of publications is increasing. So open access is one thing, meaning that open access is a policy on how to access publications and data, and cost models on how to achieve this open access. But open science is not just on this part. Open science changes the way we do science. It is much more fundamental. So let me try to give you a feeling for how open science operates. This is a picture from UNESCO, where, I mean, even at the United Nations, people care about open science. And you see many things that, well, can I? No, I don't. Oh, there. So I have and maybe I can even do this. Okay, good. So you see, around open science, we have one thing that is open access, to read without having to pay. But you see there are a whole bunch of other things: open infrastructure, education source, open data, open labs, open phone book, open evaluation, and so on and so forth. So open science captures every single dimension of how we do science, and it talks about opening it up. It's not just paper publications and data, but it's software, methodologies, educational resources, annotations, access to resources. So you want not a human, HPC, high performance computing, that to be open. We are not here, we're not there now, and it will take many years, 10 years, 15 years to get to the full thing. But this is a direction of that everything points to, and it's how we go there, how fast we go there, and where will be the points where the ways we'll exercise open access is unclear. But one thing that is clear is that all these things are open, and technology now allows us. A paper, a publication, is not the piece of paper or the XML file that we know now. It's a live, active object that has the paper, the text, it has the data underneath, it has the metadata of the system that was run on, and so on and so forth. So a huge graph of information related to the research object that is called a publication, and how to do that. This is one of the standard pictures that people point with respect to the life cycle of doing science. Most science starts from a hypothesis, okay? And then you collect the data about it, or theorize, then you process the data, you store data and results, you archive it, you publish it, you reuse it, and then for your next work. Of course, in the fourth paradigm of research that the late Jim Gray coined the term, often you don't have a hypothesis, you just start from data collection. You collect as much data as you want, and then you see what hypothesis this is fulfilled. But notice there are many things that you do in in every node. One of the things that open science asks for in its purest form, I'm not sure if we'll get there, is that you don't just publish your paper, publication and distribution. You don't just publish the results that you got. It asks you even from the very beginning to reveal. It says, now I'm working, I'm trying to solve this, and this is the way I will do it. And you reveal this. You don't keep it to yourself. Why would anyone want to do that? Well, by doing this, 90% of the time you'll fail. You won't get what you want. You'll get something else. Well, all these failed things, it's important to exist. It is a scientific contribution that I tried and I failed. Usually we try 100 things and we only present what succeeded, which could be irrelevant to where we started from. But all this is very useful. And you reveal, I'll use this data. And even intermediate or failed results. This is what I have and I will continue doing it. Now, there have to be some calibration of all this, because if you say, well, I'll work on this, then maybe someone else will jump, take it, do it. So, but this may be, in an ethical world, a source for collaboration. Exactly. I'm interested in this, I see you're doing that, and so on. And all this is about research and science that has been funded by the taxpayer, publicly funded research. So this is the right way to do it, democratizing science. And then if we go into the main things that we see, okay, we have to use open source this, open access, and so on and so forth. But you see, it has work. The way we do science and research is requires a bit of work. To do it in an open way requires more work. We need to be curating our data, putting metadata so that others can find it, even at the intermediate level. Again, produce standard metadata. You need to have comments in your code. You need to have metadata in your data. You see, publication is one thing, but the data that is used on the way, it's extremely important. And then again, publish metadata, use open evaluation, I'll come to that later, make use of institutional repositories. I'm sure Sapienza has an institutional repository where you have to deposit your papers. Well, the way is that soon you have to be depositing your data and so on in order to fulfill open science. This is the life cycle of open science. And these things, I'll come back to these numbers, but here is what is 1 and 4 in my next slide, and here is what is 2 and 3. This is a whole bunch of more things that we need to be doing in order to serve, in order to operate in open science. Let's go to what we're used to, open publications, text, none of the fancy things. When we communicate, what is called scholarly communication, we try to achieve 4 things when we have a paper. First of all, we want registration, saying, see, I am the one who did it. Two, you need validation. Someone checked it and validated it's a good work, so it can be published. Three, dissemination. Hey, the world, look, I wrote it, people said it's good, learn about it and do your work. And four, it's archiving. Have it somewhere so that next generations can find it. With print publications, these four had to be done by the same step, essentially, and by the same organization. But now, in the open science world and with the technology we have, this can be broken down. 1 and 4 registered in archiving can be in an institutional repository or in a thematic repository like Archive that computer scientists like to use. And that is enough to register. I did it and a timestamp, and then it will be there forever. But then you can validate it and disseminate it by someone else. We can have everything in Archive and then pods or Sigmod becoming and saying, let me see what is there. I'm simplifying here. My committee check these papers, and then those that are accepted, I want to come up with what is called an overlay conference, overlay proceedings. The same thing for a journal. So you can be you can be registering your work, and where it will appear, it is something that you check afterwards. And this overlay journals and overlay conferences is something that many scientific communities are looking into and experimenting, piloting, and ACM now is trying to do with some SIGs, some pilots to see how this thing works. And a related thing is, okay, if we go into conferences, publication is one thing. But why do we go to conferences? We go and stand and give a presentation. And then there's questions. And then there is discussions in the hallway. Well, the presentation, especially COVID, showed us you can have the YouTube channel, you can have something on Zoom or in YouTube, and it's not different. I mean, even now, my presentation, if it's videotaped, then someone can look at it in the end. It doesn't have to be in this room. It is a discussion, the conferring that is very hard to do remotely. So even in the open science world, the nature of a conference itself and what we will be doing in conferences in the next 10 years may change. Also pushed by issues of traveling and the environment and so on. So what publications will be in the era of open science with the overlay publications or conference or journals? And even what is journal and what is conference is now being blurred, and we don't know what it will be, because conference, especially in computer science, what we care about is the presentation. And even not that, the conference, to go and talk to people. So all of this may change, I don't know when, but I believe that the next 10 years will be very exciting, and we'll see our mode of operation change. By the way, a key thing of open science is reproducibility. You have the results, but not just the paper. All the data, everything that you use so that someone else can reproduce it. This is the epitome of science. The same thing to be done. Evaluation. What is the key process of evaluation that we follow? You have an author, and she writes a paper and sends it, eventually ends up in a reviewer. And the reviewer writes a review, and eventually he sends it back to the author through a process and so on. Yeah, in a journal, yes, in a conference, whatever, but yes. Sooner or later, yes. So this is the simplified circle of what an evaluation is. And if this is positive, you get, the world knows about the paper. If it's negative, then the paper goes back to the author, and that's it. And the reviewer goes to the garbage bin. Everyone forgets about it. This is roughly what is happening. Well, we used to have what was called single blinds, but now this is not a political correct term. It's single anonymous, okay? In the single anonymous world, okay, the reviewer sees everyone, the paper, the review, the author, but the author doesn't see the reviewer. So the spectrum of vision goes all the way here, so the reviewer sees the author, the blue. But the pink, the author goes up to here, doesn't see the reviewer. Okay. What is the problem of that? Because of various reasons, because of a reviewer hating a particular author, or feeling competitive with what is done, or because he didn't wake up well that morning, a lot of the reviews are not at the quality that we want. Okay. And then we went into double anonymous. Okay, about 10 years, 15 years, many fields within computing went to double anonymous. What does this? This is that we moved this wall here. So now the reviewer doesn't know the author. So the problem of the reviewer hating the author, in principle, okay, is gone. Okay, there are violations of policy and so on, anonymity, but let's be optimistic that this is gone. But still, not liking the paper, or not spending time. I've seen reviews. What have you been smoking last night? And you wrote this paper. And are you kidding me? Things like this, and others. So the problem remains of the poor reviews. In open science, okay, instead of going in this direction and shutting and going from single anonymous to double anonymous, we go to zero anonymous. We move this, and everything is open. And not only is it open, now the reviewer, now this is the extreme version, the reviewer signs the review. The author sees who wrote the review. And what did I do? Yeah. Now, everyone will be embarrassed to write a garbage review. They have to make sure that it's written, okay? And the timestamp of when you did it, absolutely. But also, it's not only that. The review itself goes out to the world, not just to the authors. Because in an open science, a review is a scientific contribution. Every little thing that you write is a scientific contribution. You put part of your thoughts as value addition to this work. We're not there yet. We're piloting. The PABS board of ACM is trying to pilot this with one SIG. SIG-Chi, computer-human interaction, has a track, very small track, very specific, where this is being tried. The AI community have tried it. This is the direction. Now, if we'll immediately go completely open, we don't know, because now the angry guy is on the other side. The author may be pissed at the review that someone wrote, and especially if it is, Maurizio Lanzarini getting his paper not accepted by a junior student, say, I will never write a recommendation letter for you. So, not Maurizio, because he's not this kind, but there is this fear. So maybe you open the review, but not the reviewer. For junior people, we can mitigate. These were the slides that I had to finish up, Tiziana, the animation and so on. So this is what it says. By opening up, you have transparency, accountability, and quality. Okay? And there are senior to junior bullying, but we can find ways of dealing with that. And let me go back to this picture, and let me get rid of the bad guy. There is this big thing, I won't talk about it, of the paper diarrhea. Okay? Here it is one paper, but if we look at the community, this production of paper is huge. Everyone is running around trying to publish. And open science says as a philosophy, if a review is a contribution to the world, and maybe in your CV you can say, I wrote this review, and I wrote that review, and so on and so forth. Whereas we were talking about the delta publications and the epsilon publications, which are useless, let them have it. If you need to report on small results that you have before the big one, let's have the results. Publish them in a repository and so on and so forth. But when the time comes for you to be assessed, you will choose your 5 most important publications the deep things, the culmination of the 100 little things that you published, and you helped step by step progress your science, but then you'll be assessed if you're, up for tenure, 5 important ones. If you're for full professor, I don't know, 10. I'm just giving numbers. I mean, there's nothing absolute. So the whole assessment of research in the world of open science is changing. And currently Europe, open science leads Europe, Europe leads open science. But even in the assessment, about more than 400 universities and research centers in Europe, under an effort of the European Commission, are gathering and have a manifesto of trying to identify how do you assess research of the individual person, of a research institution, of a company, of a funder, and so on and so forth, the department. In the world of open science, where just novelty of the research result is not the only thing, and size and the number of publications and your H index and so on are not the key things. And one of the mottos is, we've now assessed research by counting. We should stop counting if we start reading, and we should read the key contributions. So this is where we go. Open science in Europe. For the past 15 years, OpenAIRE is a research infrastructure that has been built in Europe. It started from just a pilot in FP7, 15, 16 years ago, with institutional repositories and some opt-in volunteer, all the way through the years in Horizon Europe, where open science is the modus operandi. You have to be depositing your data, your publications, and so on. And OpenAIRE in 2018, it's important, where the European Open Science Cloud started, a major infrastructure that combines OpenAIRE, which is focusing on open science, and also Jean for the network, CGI for cloud, and so on. And this is also a key thing, because OpenAIRE became a legal entity. So OpenAIRE is a company, not for profit, because I have been the coordinator of OpenAIRE. All countries agreed that headquarters should be in Athens. The people in the infrastructure itself are spread around Europe, from all countries of this 27 plus another 7 around it. And there are 2 leaders that really lead this effort. The CEO of that is Natalia Monola from Athena Research Center in Greece, and Paolo Manghi, who is the Chief Technology Officer from ISTI-CNR in Pisa. These 2 are the pillars of offering OpenAIRE. And of course, Europe in open science is the leader, and many countries collaborate with that. The key thing of OpenAIRE, the heart of OpenAIRE, is gathering a graph of all research objects that are important for open science. So not just the publications, but also the data sets, the software, the other resources, and all of them, which are research products, be connected to organizations, to funders, to streams of funding, sources. Every entity, this you can think of as an entity relationship model, a binary relationships. All of them are connected to each other. Many of you may be familiar with Microsoft Academic Graph. Well, this is much broader than the Madison Academic Graph that was that. And this is the data flow of all that. I won't talk about it, but you can see there are 123 million publications from all sciences. The data stay where they are. The publications stay where they are. But the metadata are gathered into this graph, where then you can do lots of value-added mining and so on and so forth. And in enriching the graph, and this is, by the way, not only open sources, but also closed sources. Elsevier, Springer, Wiley, all these have agreements, and they give us the actual data, the actual text of the publications. OpenAIRE mines them, and then destroys them because this is closed access on the commercial publications. But the entire scientific production of the world can be searched through OpenAIRE. And this is used in many ways. But in this enrichment, how do you enrich and assess and mine this tremendous million nodes, hundreds of millions of nodes and tens of billions of edges nodes to get the actual graph is something that has created challenges that came to the research part. And I'll spend 5 minutes just to give you a glimpse of YesQL, which stands for You Extend SQL. The motivation is that SQL is either you love it or you hate it, but it's a language that is not Turing complete. You cannot express everything there. You need many things when you do with data that are under SQL to do it in another language. And let's say Python, which is if you want to mine to machine learning and so on, it's the language of that. And how do you do this? SQL has what is called user-defined functions that are stored and then executed. And this is from OpenAIRE. This is one program that has SQL and user-defined functions. A small part of it is like this. You see, select, from, where in SQL. And all the red things are Python functions that we have implemented in order to process it. So there's a lot of Python to SQL dance that is going on. There are many things that you want that are desirable when you connect SQL with Python on the programming language level. Polymorphic, dynamic, statefulness, and so on and so forth. I won't go into each one of them. And if you look at commercial engines, you'll see that this desirable expressiveness characteristics don't exist in almost any of them. Very few are there. And if you look at the academic prototypes, which is much richer, okay, still many of them have very few of these. Well, SQL comes and changes this and it has this expressive power that is necessary. It stands for You Extend SQL. It is the opposite of NoSQL. That's why it's called YesQL. And the characteristics is that it's an SQL extension, a whole bunch of characteristics that enrich the expressiveness of what you do. And it affects usability and also performance, lots of things for parallelism, just-in-time compilation of Python, fusion of multiple user-defined functions, both user-defined function, but also make them operators inside the SQL. So you have a join and you have a user-defined function. Can you do algebraic things in there to the extent that you know algebraic properties of UDFs, or you can discover them. And this is something that we're working on. YesQL can be operated both in server-based database systems and in embedded database systems, where the database is running within the process of the application. You see, the difference is on the left side. Everything else is the same. And this is a small part of that query that you said, and you have all three main types of scalar, aggregate, and table user-defined functions. We have fusion. As you see, if you have two user-defined functions, one on top of the other, you can compose them and treat them as one. And the third thing is that you can have some syntax like Polish notation. Instead of saying this versus that and select and so on and so forth, you can just get rid of a lot of the syntactic sugar and help in processing. Usability and expressiveness. We've run experiments and showed with complex tasks with 380 students. Half of them used Python and SQL separately, and half of them used SQL with all the properties. And the results in terms of usability, of how many more mistakes were done, how much time it took them, completion and so on, are overwhelming in favor of YesQL. And in terms of performance, I'm just giving you one graph, which is very characteristic. This is YesQL with a particular Python library and all the goodies, parallelization, just-in-time compilation, and so on. if that is the baseline, then if you go to SQLite with the same library, or with another Python library, it gets 3 times or 5 times worse. And then we go to all the efforts of others. Tuplex, the main thing from MIT, it's 6 times slower. Pandas, which is major thing, used 10 times slower, and all the way to Postgres being almost 2 orders of magnitude. So ACM is here to serve community, so us, but we need your contribution. IEEE is primarily a top-down organization. ACM is a bottom-up. It's volunteer-driven, member-driven, means you. Open science, policy, and infrastructures, it is the way to go. Where it will end up, it depends on us. Extensive discussion is happening around the world. And, you know, during the night, I do a little bit of research with my team, or rather, my team does research, and then I listen, or I say once in a while some good thing. So that's it. Thank you very much.
Thank you, Yannis. Questions?
I went too fast.
No, Marco.
Hundreds of publishers which actively pushing people to write because of people publication. So there is push of publication which is not from the scientific need, but it's from content. Also, this unfortunately is also not taken care carefully by assessment. So I think something is out of control. Not sure that there are the safeguards. I mean, we need to have the safeguards. Utility of distinguishing between.
Let me repeat the observation. Marco was saying that open science, so the risk is that it helps multiplication of publications, which is a real problem today in, you know, many workshops, many journals, so many publications going on. So is there any, so what's your opinion about this risk?
It is not so much open science that has resulted in this, but the opportunity of predator publishers to be getting their money at the production side and not at the consumption side. So this is what has resulted in all these predator publishers, not publications. What I said about the assessment needs to change is effort that is being done, because if all you care about is the important things and all you have are not important things, then you will be assessed poorly. When we'll start reading the top N most important things and not the hundreds times N of little bit that is published, which could be useful, a little bit. Okay, I did this work and I get this little result, or I failed. This is useful, but I will be assessed on the important contributions. This is, and this is easier said than done, because nothing can be decided until everyone decides to go this way. I cannot decide it, and then my university says, no, I like that, I'm like that, or the funder. So, but this is the effort. Precisely, the politicians, the policy to be like that, you are judged based on this and that or the other. And this 400 plus, maybe 500 now institutions around Europe are working on this. And the world also will be working on that. So until the assessment is changed, we're in a transition period, and you're right, there are issues, and everyone has to use their judgment in terms of the quality of what is there. But I believe that, you know, in some depth of time, hopefully not too deep, we'll have a new way of assessing things, and this will get rid of all these predator I'll repeat the question. Her question. Oh, okay.
So I have a question somehow related with Marco's one. So I, as editor-in-chief of a journal, I am experimenting two phenomena that are growing and growing. The first one is the dramatic lack of reviewers. And the second one is the increase of very low quality submissions. Many. So you spend part of your time desk rejecting publications that are really very low quality. Now, but there should be a policy also to, in some way, try to mitigate or propose a different schema, and I don't know which one, to solve both problems or try to mitigate them.
Again, some of the things that I mentioned, which are not, currently, the accepted norm, can help there. One thing is overlay journals. Not everyone submits in your journal, okay? They put it on archive. Maybe even the community openly judges. And then you as editor-in-chief go and check what is in your field and decide to proceed. So this will help partly that. The assessment thing will change how much people will feel in submitting to go to a journal. They can be archiving things so that people can see what they have done, but they know they will not be judged on this, and they will be focusing on the more difficult things, on the more quality things, so that they will have to go to your journal. One of the increases is that the population, the scientific population is increasing, or many countries, for example, China, which has a huge population, a huge scientific population, is producing papers like crazy. They want to be in the world level good, so they're hardworking. So they write a lot of things, many of course low quality. Okay, and so this increase of production in China is not the only thing. As people increase their scientific level, we'll see more. I don't think we can do anything about it except for changing, as I said, the assessment and what a publication means. Yeah. I'll repeat his question.
You repeat it.
I'll repeat your question. I'll try to repeat the questions, and if I fail, then the second one was essentially about a document being live and the reviews to that document being live. So you have a document, reviews are coming, you have a next version of the document, more reviews are coming. It is published, but still people write reviews, and I think of that and think of that, of this or the other. If the review is considered a scientific contribution, something that you are signing and you can be proud of, and so on and so forth, this is the way to go. I mean, this is at the heart of open reviewing, and of live documents. The pilots that are, let me connect that, and your first question was, what are the indications currently from the pilots that are happening and what people believe in and what they think? I think it is too early to say. These have started, 1 year, 2 years, and so on and so forth. So it's very hard to say. So next time I'll come and I'll give the other talk. I can report on that. The AI community has tried to experiment with open evaluations and piloting and so on quite a few years back, where they would put a paper out and they say, okay, go ahead and review it, whoever wants to review it. They faced some difficulties because one of the things that Tiziana also said is there is reviewer fatigue. There's so many things that can be done, so it's hard to find reviewers. It's fun to find volunteers. You saw, I'm really glad that we are now at 500, but there's so much that you can volunteer and donate your time and expertise to somewhere. So we'll see, but the AI community, in the beginning it was completely open. Then they said, okay, but we will have assigned reviewers. So you commit that you will review this and then anyone else can review it. And currently the reviews are open, but the names are closed because, again, the bullying potential we haven't found. So it's work in progress. We're in a transition period. And we'll experiment with this and we'll go there. What will be the final, the fixed point? One of my beloved things. The fixed point, or possibly the fixed points. Maybe there's no one optimal thing, but maybe there are multiple. Remains to be seen, but the times are very exciting for what is happening in the way we communicate science.
I think that I get a message from ChatGPT saying that you have to leave.
Enough already.
You have to leave.
Yes.
Right?
Yeah.
Otherwise, we can't stay here.
Yeah,
But ChatGPT knew that you have to leave.
Right.
So thank you thank you again. Very nice talk.
Thank you very much for the opportunity, and do volunteer for ACM. I mean, check it out, and then whatever is close to your heart, volunteer. And if you have other questions about open science or anything else, they have my contacts. You can find my contacts. It will be great.
And be careful because next year he will be here.
Yes.
And he will, take note of who is going to be a member or not.
Yes. Good idea. Thank you very much.
Bye-bye.